It's very, yeah, so the question was, to what extent is the causal relation important or fundamental in building the map? It is the key, right? But in science, that's what you're trying to teach people.
That's the question. Next question is, therefore, is this applicable only in science education?
It's more applicable in science education, but you could see that it could be even applied to history, right? So in science, it's one kind of causality. In history, it's a sequence of events that occur one after another. And sometimes we just learn facts that this happened at this period of time, and then this group conquered that group. But you miss the reason why, as to how it transitioned from, say one kingdom to another kingdom. So by building these kind of more detailed maps, maybe you will get a better understanding of history. It can be used in economics because you're looking at cause-effect relations in economic models.
Can I just add one question to that, and maybe we can discuss it after that. Therefore, to what extent is this important or dependent on the teacher? Because very often when you teach, teachers have different sequences by which they would like to emphasize something.
Right.
Therefore, are you suggesting that there are going to be multiple models like dependent on the teachers?
Absolutely. So the teachers can build their own models. So what I didn't tell you was underlying what the student is doing is an expert, what we call an expert model, that is being used to evaluate the student's work. The student never sees that expert model. But our goal is that, all the resources, the units that the students have to read to learn, and the expert model will be built by particular teachers who want to use it in the classroom. So our system is general enough that we provide this representation and the system, but the resources that are built, the expert map that is built, is constructed by individual teachers. So thus far we have worked with teachers to do it, but we are developing tools by which the teacher can do it on their own once they gain an understanding of what this causal model or causal reasoning means. Yeah. Thank you. Uh-huh.
Can you try to see that the things which you found out is a reason why? Can you improve the ones who are not doing well?
Yes. Yeah, we have. And so another thing that did not exist in the original version of the system, where we were focusing just on strategies, we have had to build in. So now we have tutorials in the system. So we find if the student is not able to find links while they are reading, we say, let's stop working on the system, let's work on a few simpler problems. So we'll give them a sentence and say, can you find the causal relation in this particular sentence? And we go through a set of exercises like that. When we find that the student is getting a few of them correct, we then say, okay, let me take you back to this paragraph in the real resources, right? There is an important link here. Now let's see if you can find it. So for students who don't do well, say those who are not able to read, and that happens a lot in the States, you'd be surprised, right? Or they are not able to do different things. We hold their hands, right, and provide them with tutorials on the system itself to sort of overcome these lower level cognitive activities that they need to know before they can think of metacognitive activities. Uh-huh. Uh-huh. Right. This is an excellent question. So, we've had things both ways. So sometimes when we've gone into the classroom, right, we felt bad because we tell the teacher, after you've taught this unit, the students are going to require 4 or 5 class periods to build a map. But it's clear that that's an interruption to the teacher, to what the teacher tries to do. So what we have tried to build in is and I talked about that 2 years ago, are tools where as the students are working, the teacher gets an idea of how the whole class is doing and how individual students are doing. So therefore, it's not that the system is standalone. So say the students work on it for 2 days. The students review where they are, the teacher reviews where the students are. On the 3rd day, she says, before you work on the system, let's have a discussion, right? So you don't seem to understand, right, how the greenhouse effect causes sea ice to melt. So let's discuss that phenomena. And she might even use examples of maps where students have done it right versus they've done it wrong, and get the whole class to discuss it in an anonymous way. They won't say that, Peter did this and Mary did this, but she'll just say, here are 2 maps I found. Let's discuss this. There's a difference between them. What is right, what's wrong? So we try to bring in the teachers a lot into the process. The idea is to use technology to help teachers, not use technology to replace teachers. Now, to answer your question fully, there are some teachers who don't like sort of taking up this much time. So for them, we recommend that as technology improves, maybe students can use the system for homework. Another thing I should tell you is any of you who are interested, right, could go to our website, teachableagents.org, and request a copy of the system, and we'll give you a login account and you can work on it. So we could allow students to do that, right? So the teacher teaches in the class, and then she gives them homework where she says, over the next 4 or 5 days, you build a map. But the teacher can also monitor what they're doing because all the information is saved on the server. So as they're doing their homework, she can interject and help them in parts.
Running out of time. We got time for short questions. There is one question from here.
Yeah.
Short questions.
What is the criteria to decide a high improvement is also? Can you give some subjective parameters?
So what we used in this particular study was those who had high map scores, which means they had most of their links correct, versus those who had very few links correct. So that was the high versus low. We were looking at performance and then trying to link behaviors to the performance. Yeah. Uh-huh. Right. So that's, when you do sequence mining or hidden Markov modeling, that's what you're doing. You're abstracting the sequences to a form where hopefully when you derive these patterns, they are the ones that are relevant, right, or prevalent, right, which means that you're not paying attention to sort of actions or action sequences that happen very, very infrequently. So that's one way of getting rid of noise. Right, but the other thing is students do a lot of irrelevant things, and it's better to catch those and discuss that with the student than to just ignore them, because you think that that's not the way someone should learn. You'd be surprised when you do this kind of mining, what kinds of behaviors you see in the student, right? Things that we've never thought of before, and therefore it's very useful to do this kind of analysis, not just consider it noise, because if a number of students are doing it, right, that means they seem to have misconceptions.
Sorry to interrupt this discussion. I'm very sorry about it. But at the same time, I feel that please do talk to him after this part is over. Let's now break for tea so that we can start the next session for time. Before that, let's thank Professor Gautam Biswas.
Thank you very much. Okay.
Please upload your presentation in the room where your talk will be held. Everything is ready.
Thanks. I had lots of questions also. I'll ask you later.